Okay, here is the walkthrough for the code on the Picaxe end of the Glen Stove project. The Picaxe, in this case, is nothing more than 5 ADC inputs and a serial connection out to processing and a serial connection for the LCD screen. The serial connection coming in from processing is right here, and I'm using the H serial pins, which are important because that allows you to use interrupts, and I'll show you what that's about. H ser setup, the baud rate, and then the parity in 8 bits, etc., and then this these 3 bits in this binary guy right here. Those have to deal with how you want Picaxe to deal with the data coming in. And it has been forever since I've written anything in Picaxe, and even longer since I've dealt with this code. But nevertheless, I can vaguely remember that these set it up for a background buffered receive with an interrupt. A background buffered receive. Set your interrupt flags. This is the setting up the interrupt and the mask for the interrupt, and basically this right here tells the Picaxe to set up an interrupt. Keep doing whatever you're doing, but whenever you get any kind of serial data on these H serial pins, go ahead and jink down to the interrupt routine, which has to be at the bottom. It has to be labeled interrupt. It has to be at the bottom of your program, and do whatever's in there, and then get back to whatever you're doing. So that's the interrupt routine. A clear screen, that's a subroutine to clear the LCD. Setting up variables, this is like you would set up variables in any programming language. Display loop. This is basically just the serial commands to make the LCD display work. This is nothing special. And here, let's Fahrenheit living equal raw temperature living times 72 divided. This is the conversion to go from the ADC numbers to actual Fahrenheit degrees. It assumes that the thermal resistor is putting out a linear temperature curve, or its numbers are linear. They are not, but Jesus Christ, close enough for what we're doing here, for crying out loud. And these are just the display loops. After showing each one, it goes through and checks to see if any of the buttons have been pushed, the input buttons on the front of the little control box. And basically, because Picaxes run so slow, that I've just used these subroutines to slow the whole program loop down enough that each of these is displayed for a couple seconds, enough for you to see it, and it works just fine. Again, more. Oh, these are being shown. These are the things that's shown on the LCD, but they're also like menu options and stuff. Here's the check buttons routine. It's just checking if input buttons have been hit. See, if pin C equals 0, then the button has been hit. This is not hard stuff, ladies and gentlemen. This is here's the 4 read ADCs to read the 5 read ADCs. These are to read the 5 temperature sensors put around the house. And actually, oh, here's my slowdown right here. I was saying that I actually am using the loop to slow down the what's being shown on the LCD screen. Yeah, I'm checking the buttons 255 times each time, and apparently through checking the buttons and checking the ADCs, it's slowing this loop down to a couple seconds, which is enough here that every time I show something on the screen and then check the buttons, this check button routine turns out to be a couple seconds long, allowing this to be displayed on the screen long enough for the human eye to see it. Damper adjust. These are just menu options to adjust that little motor that controls the window. I'm really not going to go through this. This is just basically reading ADCs and adjusting a servo. This is very simple stuff. And if you don't know how to do it, without sarcasm, go blink an LED. Go learn how to make an LED blink and get to this. This is step 487. You don't try this if you're on step 3. More menus. There's a pot on the control box, and as you turn that pot, these menus are shown, and you're able to select it if you hit a button. Nothing too fancy here. Look at it, it's all menus and LCDs. Here's some magic. Here is the interrupt routine. Processing at a given time, at a given rate, will send a capital N to Picaxe, and it's going to get caught right here. Here's the interrupt. Now, pickaxes are wicked slow, so the first thing I'm going to do is wait 25 milliseconds just to be sure that all the data has gotten there. In this case, it's only one single byte. Nevertheless, hey, it's a pickaxe. Give it a break. Give it a second to think, all right? If first byte, so here, get, I'm ahead of myself. We set up the interrupt routine here and the buffering, okay? This HSAR setup and these 3 bits of this binary shenanigans right here, that basically means that when data is received by these HSAR pins, it's going to be stuck in the scratch pad of the pickaxe. The scratch pad is just a little nook and cranny that the pickaxe can store bytes. They're stored at where the pointer is, and in this case, we have it set up to reset the pointer to 0. So it's always going to write its data starting at mailbox number 0, and it's going to write sequentially from there. When you want to get that data back, in this case, after it's interrupted, and it knows that you have gotten data, this get 0, this guy right here is the get data from the scratch pad where it has been written when that data came in the background via serial. So we're going to get whatever byte is in mailbox number 0, and we're going to stick it in variable first byte. If that first byte is N, which it will be unless the data puked on its way over, then go sub take reading. And this is the routine to basically just go check the ADCs, get that data, and send it off. I'll show you how that works. Once we're done there, we're back from the subroutine. HSAR pointer, reset the pointer, for crying out loud. Okay? So it'll start writing at 0. So the next time through, when you go to this get 0, it'll be there at 0. Reset your flag. This is wicked important. HSAR flag equals 0. You gotta reset that serial flag. If you don't, when it leaves this interrupt flag or interrupt routine, this flag will still be set. It's going to go back to wherever it came from in the main loop, and that flag will still be set. So it's going to go right back to interrupt again, and it will keep interrupting over and over and over and over and over, and your loopy loop won't loop, and it'll drive you nuts, and you won't know what's going on. So reset your damn interrupt flag. That screwed me over and over and over. And reset the whole interrupt system right here. You got to with these, this is the mask and the interrupt flags. Look up this command in the manual. Familiarize yourself with it, but the point is, this can be used for a whole lot of things, interrupt pins included, and the serial interrupt. So this is a great command, and you have to reset it right here on your way out of the interrupt loop. Okay? So pretty simple. Interrupt loop we have interrupted, we've gone there automatically because we got a serial send. It happened in the background, it got stuck on the scratch pad. Get it from the scratch pad from mailbox number 0, stick it in first byte. If first byte is an N, then we know we need input, or processing does. Go to the subroutine that does that. Get back here real quick, reset the pointer to 0, clear the flag, reset the whole interrupt system, and get back to what you're doing. Alright? Last thing, take reading. Let me see if I can find that. I have not. It has been so long since I've gone through this code. Golly gee whiz! Check buttons. Display loop. Man, it has got to be here somewhere. Main menu, set voice, adjust time, set manual auto, new fire, take reading. Bingo. Read the ADCs. These are the thermal resistors. Pretty simple. Convert all the numbers to Fahrenheit. Like I said, this is a wonky way of converting, but it works and it's accurate enough for what we're doing. Here is HSARE out. The 0 is if you want to send a wake-up byte. We don't want to. This sends the data to processing. Okay? And it's going to send it via the HSARE pins, not the regular sync serial pins, but the HSARE pins. And this is basically just putting together a string, and I'm using a colon to separate each byte in the string, and then processing will deal with that. Here's the qualifier to say, hey, processing, I'm going to send you 5 bytes, and they're going to be temperatures. They're going to have colons between. And then there's a carriage return at the end, because I like to sandwich all of my data so it's clean. Qualifier, carriage return, data in between, clean packet of data from a start to a stop, data in between, and it stays clean that way. Send it off to the LCD to say, hey, we sent it, basically for debugging purposes, and then return and get back to whatever you're doing. That's it. That's the whole Picaxe side of this. It's very, 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 very simple. The main thing, the magic really, and the point of this whole walkthrough are these 2 commands right here. HSARE setup and the interrupt setup. That's it. And the interrupt routine down below. So there you go. You may watch the other videos about how the Twitter API was set up, how the processing end of this was set up, and I don't know if I'm going to do videos on the schematics or not, but there you go. There's the Picaxe end of it.